All right, it says when people, we're talking about hand folding here. It says when people fold their hands together with interlocking fingers, most people are more comfortable with one of two ways. In one way, the right thumb ends up on top, and the other is the left thumb ends up on top. And we looked at a group of people. We looked at M is for man, W is for woman, and right means the right ended up on top, and L means left ended up on top. And we want to know, are the events right thumb, right on top, is that independent? Is this is the event right? Is this independent of being a man or of gender? Okay, independent of male. Okay, and that's what we want to ask. Okay, so here we've got to figure out if things are independent, the probability of A given B is just going to equal the probability of A. So in this case, we want to know is the probability of choosing the right hand, given that someone is male, is that equal to the probability of preferring the right hand on top, or right thumb on top? Okay, so we've got to figure out these numbers. So first we have to figure out the probability of being right-handed, having your right thumb on top, or probability of being male. And so here we've got to do some addition here. So here, male, we have a total of 30 males, and here we had a total of 70 women. And over here, 18 plus 42, we have a total of 60 people who preferred their right hand on top, and of those who preferred their left hand on top, we had 40, for a total of 100 people. And we want to know, is the probability of being of preferring your right hand, given that you're male, is that the same as the probability of preferring your right hand on top? So the probability of preferring your right hand on top is there were 60 people total that preferred their right hand on top out of a 100 people total. So that is equal to 0.6. On the other hand, the probability that someone prefers their right hand, given that they are male, this is going to be the probability of having your right hand and right hand on top and being male, divided by the probability of being male. So this number, right hand on top and being male, there's 18 people, 18 males that preferred their right hand on top and were male out of 100 people total. And the probability of being male, there was 30 males out of 100 people total. And so this ends up being 18 over 30. And when you do the division there, indeed, that also ends up being 0.6. So here we see that the probability of preferring your right hand on top and being male is independent. Probability of right hand given that you're male is 0.6. Probability of preferring your right hand is also 0.6. So here we see that the probability of right hand given male is indeed equal to the probability of preferring your right hand. We have 0.6 equals 0.6. So this means yes, they are independent. Okay, and the interesting thing is that when you just have two categories, right or left, man or woman, if right and male are independent, then that means right and women are independent, male and left are independent, women and left are independent. Those are the combinations between hand and gender are all independent. That only works for when you have two categories in each group.